Yes. And today we will continue on from the lecture on Tuesday, right? And on Tuesday we do we go over this concept called pointer. And to recap, right? Whenever you have a use of a data, like something like int a equals 10, right? In this case, a is a variable, and the data value of a is 10. You can also get the address of A, which is basically, if you look at the physical location, the actual location of the electron, you can use this physical address. You can use this address to tell where they are inside your DRAM. And the concept of having this address kind of ties to this pointer concept. The pointer is the data, but instead of storing the actual data, pointer store the address. A is now the pointer to store the address, and the address is pointing at the data that has the value 10. So star A in this case is 10. You can use ampersand on a variable to get the address. And you can use store on a pointer to get the value. So you can use this thing interchangeably. You can make the pointer points to some other variable. You can also make a pointer point to other pointers as well. So let's say you want to make a 2D array, right? But you want to make it dynamic so that each row can extend as much as you want, basically. In that case, you first create, right, a pointer, which is the first dimension array. Each one of them is a pointer that points to the row content. You get to try this on the question that calculate the determinant of a matrix. Right? This is on assignment. And you can do operation on the pointer. You can do plus plus or plus 1, plus 2, plus 3. So to be honest, this is a little bit short form that will not compile. So the question about the star A and what's the address and what's the data. So this is kind of like a short form that I want to type here, right? In reality, what you have to do is to int star A in the beginning. So this is now the address. A will store the address. And then you would malloc space for A. Now A has a legit address, and to assign a value to that location, you can do star A equals 10. It would actually now, at the address where A is pointing at, the value now equals 10. So hopefully that answers your question. And we also have this notion of the now pointer. Yes, we have to malloc first. Basically, every time you use a pointer, don't forget that a pointer, initially, it doesn't point to anywhere. If it doesn't point to anywhere, you don't have a room to store the data, so don't forget to malloc, right? Pointer, initially, as I said, is a now pointer. It doesn't point to any valid location. So in C, you can assign a now pointer to a value. Assign now pointer to a value. This pointer will not point to anything, and accessing the value of this pointer would generate an error because basically it's illegal access, right? You also have the data type tie to the pointer. So you point to an integer, it's going to be 4 bytes. If you point to a character, it's going to be 1 byte. And you can check the size of the data type using the command sizeof. And to allocate an area for your pointer, you can either do, well, most of the time, if you have array or a static variable, it's done statically. But if you have a pointer, you can use malloc to dynamically allocate. Initially, when you first run the program, you don't need anything for this address. Don't allocate them so that you don't waste the DRAM space. Then someone want to store their data, then you malloc. You malloc whenever there's a demand for the space, right? This command basically find a free location in DRAM and allocate this location for pointer A. And think of this as like you have a system that go and find an empty land that can fit 10 integer for A, and then A will take this address. So now you have this concept of a pointer. What are the use of this pointer? First of all, you have dynamic memory allocation. You can implement many data structure like a linked list or a tree, right? You can pass data into functions. You can passing data out of the function. You can return one or more than one thing, like pass in pointers, then modify the content. Pointer can also be assigned to a different function, and we can go through this later, right? Uh, this is basically function pointer, this concept of the function pointer. So one thing that we covered earlier is when you run a program, right? Oh, it can depending on the compiler, to be honest, and the version of the compiler. When you declare a pointer, you can also get random location as well. But just remember that random location should not be used. So a safe way to do to work with pointer is you might want to manually assign to now, right? You might want to manually assign to now. Uh, what else? So pointer can also point. I believe the current version, yes. I believe the current version, yes. There was some older version that would give you some random value. So it does depend. The safest way is to initially you would manually assign that to now. That's really safe because if you suddenly by accident you use the pointer, you know that it's not someone's random data that you have no you that you should not be able to access, right? So one thing about the pointer is that instruction, right? Your program is in the main memory. Your program is stored in the main memory. And what does pointer do? Pointer store the address, right? Pointer store the address. So what you can do is this means you can use pointer to point to this function, right? Essentially, it's in the memory. It's one of the address. So you can use pointer to point to a function. Are you still with me so far? So instead of pointing to a data, now you point to the location of that function. And the way you do this is you can use this concept called function pointer. We'll go through this code one step at a time. Don't panic. Don't panic. One step at a time. Notice that we have a function pointer. Oh, okay. Let's first go line by line. What's the first line that you see here? What is the first line that you see here? What is this thing? What does this function do? It's a function declaration, and what does it do? It returns a plus 10, right? You increment an argument that comes in by 10 and you return it. Simple, right? So instead of calling this function like func0, I want to be crazy and fancy. I mean, to be honest, there are uses for function pointer for sure. But I want to use a pointer and I want to call my function through my pointer. So what do I do here is I want to first have a pointer point to this location. My pointer would point to this location. And then I'm going to pass the value in through my function pointer. Through my function pointer. And let me name that function pointer this funcptr. That's the name of my function pointer. The way I declare this is the way I declare this is the type the type that you put in at the beginning, the type that you put in at the beginning, which is this, has to be the same type as the return. Has to be the return type of the return. So anyone want to take a guess? What is this thing in here? What does it have to be the same as? the argument, right? So the thing in parentheses after the function pointer have to correspond to the argument. So if it's to int, you can say int, comma sign int. Why is that the case? Basically, this kind of declare is the function pointer that would point to the function with these kind of format, with these kind of format. Then when I have a function called func, right, this, right, I can get the address using ampersand. Now you have the address of my function. Now you have the function pointer point to this function call. And to use this function pointer, similar to a data, right? Similar to how you use a pointer normally, star func pointer is you dereference this pointer. You now have the function. And then inside the next argument, that's your input. So what will get print here? What will get print here? Ten and 10. Yes, it's gonna be 10 and 10, right? So you can imagine, for example, you want to use another function that performs sorting, right? I want to sort number. If I want to sort this number by sorting from smallest to the biggest, right? From smallest to the biggest, I can call my sort function. The sort function will compare things and sort so that you have 2, 3, 4, 7, 8, 10. With me so far? I want to use the sort function that do something with my input so that I get 2, 3, 4, 7, 8, and 10. But let's say I want to reuse this sort function again, but instead of smallest to the biggest, I want to sort from the biggest to the smallest. What are the only difference here? What are the only difference here between the first function and the second function? What are the main difference? It's how you compare, right? Instead of comparing which one is smaller, now you compare which one is larger, right? Which one is larger? So what you can think, the way you can think about this is essentially now you look at this sort function, everything behaves the same way, but the way you compare, right? You would have to compare function, compare one and compare two. And the sort function can have a function pointer that point to the correct compare function. So that if you want to do sorting from smallest to biggest, you use compare one. Use function pointer now points to compare one. If you want to sort from the biggest to the smallest, now the sort function would use a function pointer that assigned to compare to. This way you can reuse my sort function. One thing that I would recommend you to try is to look at the function in standard library called quicksort, qsort. It actually allows you to put in the function pointer for your compare function so that you can compare biggest to smallest and sort from biggest to smallest. You can compare even character or string. You basically have to tell how do I compare. You give in the function pointer for the comparator, the compare function, right? So quick note on function pointer, Notice how I never have to malloc. No malloc needed, right? Notice that there's no malloc here. Anyone want to guess why we don't have to malloc? Why don't we need to malloc at all? The function size, yes, function size are known at compile time. Even the address of that function is known. I know where to point. So there's no malloc needed. It's already allocated. It's already allocated. All right. You can get the address of the function using the pointer because you know the address. You know the size of the function and even you know the address. Once we are on the assembly part of the program, you will see this. You basically know the address of each line in your program, not just function name. You know the address of every single line in your program. All right, are you with me so far? Basically, the address of every single line in your program is also known. The pointer can also be an array, which means you can have arrays of function pointer as well. You can have array of function pointer. And it operate like a normal function. C know exactly how to deal with function pointer, and it operates basically the same way as the normal function call. Right? And many of the C library, like the quicksort, right? The quicksort from the earlier example, you can call the quicksort by throwing in an array, convenient, right? Throwing in the array and the size, as well as how big is one item, and you put in the function pointer. It's a function pointer that can allow you to basically compare in a different way so that you can sort things based on your demand for any data size, for any data size and data type. As long as the compare function can compare the data of that type. This is also useful as what we call a callback function. It's a callback function. What does it mean? Anyone here write a program that want to do when this thing happen, call this function? Why would we need something like this? When this thing happen, call this function. When this thing happen, call this function. Why would we want that? Error handling is a great example, right? If divide by zero happen, call this function because something bad happened, right? Uh, maybe you're listening to packets, right? Maybe you're listening to some packets that you're waiting. When the packet arrives from the internet, call this function. Anyone hear about this thing called IoT? Internet of Things. Essentially, it's just a bunch of devices connected in the network, right? And the network, by the way, the network doesn't have to be connected to the internet. It can be any network. That's where a lot of people in Thailand goes wrong. Like, why do you have to always connect to the internet? It's the interconnection of devices in the network. It can connect to the internet. But anyway, you can send data around each of these devices, right? To tell the information, what did I gather, right? You can use this callback function to say, hey, if this event happened from the other device, call this function. You can use function pointer for these kind of application as well. It's gonna be a little more advanced because you hook in the network part, right? But these are useful. These are useful to use as a callback function. So the callback function, you might see in it in future classes. We are not gonna test you on this, but function pointer can be used for this. All right, so that's it about function pointer. Any questions so far? Any questions so far before we transition into data structure? And as I promised, I'm gonna make sure that if you never take data structure before, you should be able to understand at least the stuff that we talk about this in this class. It's just no question so far, right? You can use pointer to create data structure. Pointer can be used to implement things like a linked list or a tree, right? And this basically apply to the concept of anything that I require get next item. So I can use pointer to point to the next item. And here's a general guideline. Here's the general guideline before we go into the implementation. All right. And also explaining what are each of the data structure. General guideline is this. I would first create a struct. Like the struct consists of two main things. The struct consists of the actual data that you want to store and a pointer that points to the next item. A pointer that points to the next item. This can be one item or multiple items. You can type up the struct so that it's easy to declare a new node, right? And then you declare a pointer that points to the first item in my data structure, and then you malloc to add new things you malloc. And you play around this concept in both our in-class exercise. Well, actually, it's a live demo. The in-class exercise for the just normal pointer usage, so it's a lot easier. I'll demo and write a code that do the linked list. Basically, it would have insertion, deletion, and printing things in the linked list. But let me go through some basic concepts, right? Let me go through some basic concepts first. So anyone here that use Python, anyone here know what is a list, or anyone here not familiar with the concept of a list in Python? What is a list in Python? If you, yeah, it's a collection of items, right? What's the difference between a list and an array? It's dynamic. You can keep appending, right? You can keep adding things in, right? In Python, you can do something like this: 1, 2, 1, 3, 4, 5, and then you append, and then you append 6. Now your list would expand from 1, 3, 4, 5 to 1, 3, yeah, sorry, 1, 3, 4, 5, 6, right? This is useful. How many people use this list all the time when you write program in Python? So let me ask you this question. How can I create the list in C? How do I create this list in C? There are multiple ways you can do this, right? And one of the ways is called linked list, but let me brainstorm a little bit more first. How do I create the notion of the list in C language? Can we use what we learned from last class on pointer and dynamic arrays for this? So one way, yeah, use pointer, right? One way you can do this is to have initial size and you keep expanding when you need more, right? So basically you can have a pointer that have 5 items. If you want to add the 6th item, you use dynamic memory allocation. Expand the pointer so it now 10 items and so on and so forth. So that's one way you can do that, right? One way you can do this. Right? Pointer. The second way you can do this is called a linked list. Right? A linked list. So let me kind of visualize what is a linked list. What is a linked list? The way I'm gonna visualize the linked list is something like this. Let me use the next slide for this. I would create what I call a node. A node basically is store the data, right? So let's say it's a list of integer. A node would consist of integer and one single integer per node. How do I append? How do I append into this linked list? Yeah, basically the tail of this list, right? First of all, I would create another node that store an int and make sure that there's a way for me to tell, hey, this thing is not ending, it goes here. That's the second item, right? What is a perfect type of data that I can use to point to the location of the second item? Pointer, right? So this thing is a pointer. So now again, you have a pointer that is ready to point to the next item. So if you want to extend again and have the third item in int, right, and pointer, this pointer now points to here, right? So now we have three items. This is actually called a linked list. Now let me ask you one question. How do I tell that that's the end of my linked list? You say, hey, this pointer value points to nothing. So I use the ground symbol. So in electrical circuit, when you see this, it's a ground symbol. So we use this a lot in drawing. For linked list, I typically would use this ground symbol. What does it do? It points to nothing. Basically, it doesn't go anywhere. And how do I tell that where is the first item? Where is the first item? Well, I'll use a pointer, right? To point to the first item. Yeah, some pointer that say, hey, it's ahead of my list. So this is basically a high level structure. Like this is high level structure. Let me go into more detail on how do I actually do this. So, oh, okay. So it's actually orthogonal, I think, because linked lists use the concept that you can dynamically allocate things that your pointer is pointing to, right? So every time you add something to your linked list, you would allocate the space for a new node, right? So you allocate that so that you can point to the node. So this is how you can do it, right? In C. One thing you can do is called struct node, right? Int I. So that's the data elements. It can be anything. It can be integer, character, string, two integer, five integer. Is fine. You can just put whatever you want to do. What's missing here? Inside the node, there's a data elements and what else? What else? I have I have this part. What am I missing? I need this part, right? I need the pointer. In my node, I need the data part, which is right now it's an integer. And then I need a way to point to the next node, right? Are we all with me? Are you all with me so far? Are you all with me so far? All right. So how do I do that? It should be a pointer, right? What's the type? What's the type of this pointer? What does it point to? It should point to this node, right? So the way I do this, I say the type is a struct node. It's not a struct node only. It should be a struct node pointer. And let's say I call it next, so that I know, hey, it's gonna be something next, right? So this is how I create a node. This is how I create a node. In the demo today, I'm gonna have a full blown, right, the way you can initialize this, adding things, deleting things. So you can then use, right, this whole structure to create a linked list. Initially, it can be empty. Now you can have a struct node pointer that say is the head, right? HEAD. And initially it will be set to null, right? There's nothing in there. And then when you want to append something into this, right? Something into this, then you can say struct node. pointer temp equal Monolog. What's the size? What should I put in here? The size should be equal to struct node, right? Now you have the temp as a pointer that has the size of struct node that are being allocated already. Then you can do head equal temp so that you have something pointing to this node. And then you can do whatever. You can do assign the value to this node, etc., etc. Right? I'm gonna show you in the demo today. The next thing is I want to also show what's a queue. What is a queue? Actually, what is a queue? Do we cover this in Python, the first programming class? I just want to double check. Okay, a long pause. I assume that's not the case, right? This is not covered in Python, maybe. So what is a queue? Let's assume we are normal human being with proper human etiquette. What is a queue? Let's say I queue up for something. What's the property of the queue? If I go in first, I should be the first that gets the service, right? First in, first out. We use this for many, 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 many things. The word queue by itself it becomes a noun and a verb as well. You can queue it up for something, and that can be I can refer to a queue, right? So the concept is first in, first out, and we can create a data structure for this. Why we might want to do this? Why might we want to use a queue, right? Why might we want to use a queue? So we want to imitate the real life queue. So I have something that goes in here. Basically, these are data, right? And then the data can goes into the queue so that someone else can take it and process the data, right? So what can I use the queue for? Many, many, many things, actually. You can use the queue to implement any first in, first out type of data structure, right? Anything that demands first in, first out. It behaves like a queue. We want the behavior to be like a queue so that you can sort things and order, right? Order how you want to deal with any items in my queue. So I can implement the queue in C multiple way. Let's say I want to use the array for this. What's the easiest thing I can do? If I want to use an array, and let's assume my queue will never go beyond 10 entries. There can be no more than 10 things in my queue. How can I implement my queue? The easiest way to implement a queue in C is this. First, I will have a integer that say front, right? Another integer that say back. And this is a of 0. This array a of 1, a of 2. So this back is 2, front is 0. A of 3, a of 4, right? Because there are 10 items, this is a of 9. And there are mainly two operations that are basically related to queue. You can have NQ and DQ. If I'm basically, let's say right now the queue has the item 782, right? What does NQ do? Anyone want to take a guess what does NQ mean? Yeah, put new things into the queue. So let's say I enqueue 4. I want to put 4 in here. I want to put 4 in here. One thing I can do is to say basically, right? Basically, this is going to be A of what? How do I put things into the A3? I know that back is number 2. So this is basically back, right? Plus 1 equal 4 equal this input, right? And then I do back plus plus. What does it mean? It means I put 4 in here and I move back from 2 to 3. So now it points to here. So that's the NQ. DQ is taking things out of my queue, taking things out of my queue. So let's say I DQ and it doesn't take any input because right now, basically what I do in the DQ is take it out, return this, and then move front to this, right? So first of all, I would take out the return value equal, right, A up front, and then you increment front, and then you return the return value. So that's a great question. You don't really have to, right? Because when you keep NQ, 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 once you're here, it's gonna loop back to here and it would replace anyway. There's no way, if you write the code correctly, there's no way you're gonna be able to look into this data and use the DQ operation to get 7 again because your front is moving already. So you don't really have to set the value inside the thing you DQ to now with this array implementation, right? With this array implementation. And then just make sure that you don't DQ when it's empty and you don't NQ when it's full. So that's a little bit more like if else condition to make sure it's still operating. If there's no items in here, don't DQ. If that's full, don't NQ. Don't put more things in the queue. Okay, so those are just if else, right? All right. Any questions so far? Any questions so far? So the next thing is called a stack. Anyone heard about this word before? All right. Some of them, yes, Stack Overflow. And it actually has the reasoning why we call it Stack Overflow. What is a stack? What is a stack? So a queue is first in, first out. A stack is the inverse of that. So what is the property of the stack? Last in, first out, or first in, last out, right? Basically, a stack would look something like this. I can push item in. So if I do push 5, so let's say right now that's 4 and 10. If I do push 5, 5 will be put in here. If I push 10, then I put 10 in here again. If I pop, whenever I pop, this thing go out. The topmost part go out. So the first that go in will be the last that go out. You can use the stack for many, many things. The reason is, well, actually one of the reason why the Stack Overflow website is named that way is there's actually quite a lot of structure in your computer that implement using a stack. And the word Stack Overflow typically means that you keep putting in and it's full, so it's overflowing too much. And one of the components that you're gonna learn in the third module when we go into assembly is the function call. Use the stack. When you have new function call, you push the function into the stack. You have another call, you push the function into the stack. So that way your computer knows exactly where to run the code, what lines. When you finish the function, what lines should I come back? Right? So to implement the stack in C, again, there are multiple ways you can do this. The simplest is to use an array. And because I want to make sure I don't start my array from the right, like what I did in the queue, which is a mistake. I want to make sure I start the array. A0 is here, A1 is here, A2 is here, A3 is here. And with the implementation of a stack, it's actually easier, right? I would maintain a variable called top. Anyone want to take a guess what does top mean? What should top points to? So let's say my array has this value 2, 4, 3, 8. It should point to the top of the stack. If you push, let's say I push 5, what should happen here? If I push 5, basically what I can do is A, right, top plus 1 equal 5. And then top plus plus, right? Basically, this would put 5 in here and then change top so that it points to here. If I want to pop, basically what I do is return value is going to equal A at top, right? And then top minus the decrement top, so this thing go out, and top now point to here again. All right, and as usual, like kill and like well, when you do insertion in the queue, NQ and DQ, when you push, make sure it's not full, otherwise you have stack overflow. When you pop, make sure it's not empty. Make sure it's not empty, because if it's empty, there's nothing for you to pop. All right. Any questions so far before we go to the last part of the lecture portion, which is the binary tree? This is probably the hardest part. This is the extra credit for your assignment too. Any questions so far? If not, can someone tell me what is a tree? What does a tree, even in nature, what does it look like? Yeah, it's tall, fluffy things that have roots and grow up, right? So if I have a tree, it will grow up like this, and it would have multiple branches, right? This can grow into different branches, and then I just show how poorly my artistic skill is, right? And you have the root, and this branch out into multiple branches, and then over at the top you have the leaf, right? You have the leaf at the top. So these same concepts can be used as a data structure. It's a structure that you can use to store data. Many applications in the world use the tree as a way to store data. For example, I believe everyone here uses their hard drive. I mean, otherwise you don't have a functioning computer. Hard drive use a version of a tree to store where is your file. It uses a version of a tree to store where is your file. That's how you can manage to find the location so quickly, and then you can keep adding file, deleting file. You can use binary tree, for example, to sort things. So anyone want to take a guess? What is the binary tree? Binary mean two, right? So it basically means if you have a root, you can branch to the left and you can branch out to the right. There's a phone call. Let me check that phone call quickly. All right, I'm back. So yes, binary tree is a plant, but it grows when it branch out. It goes only like two ways. You don't branch like multiple ways. So you can do left and right, right? You can do left and right, and we can use tree for many things in computer science. And if you think about it, if you look at linked list, which is what we learned earlier, can we map linked list to a binary tree in some sense? A linked list basically it grows into one direction only, right? You don't branch out. Binary tree, your node, right? The node consists of the data, and it should be able to go to the left or going to the right. It should be able to go to the left or going to the right. So here is the overview, right? Overview. So I'm gonna draw a node like this. Right? So this entire thing is now your struct node, right? What's the difference between a node in a linked list and a node in a tree? What's the difference? It now contains two pointers, exactly, right? So the left pointer again point to another node, right? Node data, and the left pointer and the right pointer. And then if it's the leaf, right? If it's a leaf node, this thing points to nothing. So it doesn't point to anything. The right, for example, in this case, is stopped there. So it doesn't point to anything. Right? So you can keep going. And again, inside the node, the only difference here is struct node would consist of mainly three items: the data itself, it can be integer, string, or whatever, right? And then left and right, and left and right. And then when you have to insert things, you would assign. If you want to insert to the left, make sure the left now point to the node and don't do anything to the right. If you want to insert to the right, make sure you assign the right pointer to the correct location. You just insert and don't modify anything in the left. Right. And then you make sure you have the root, right, that points to the first node. And again, when you have a leaf of the tree, right, the leaf of the tree, you have the data, right? That's the same. And then the left, both the left and the right has what value? It doesn't point to anything anymore, right? So this should be now, and this should be now. And that's a great question on the chat to say, hey, can we create a node with generic data? Yes. The data that goes in there can be anything, right? It can be anything. It can be a metric even, right? You want, you can do whatever you want that goes into the data. So hopefully that answers your question. It doesn't always have to be an integer, depending on what you want for your program. Depending on what you want for your program, you can maintain the data structure that store the data that you want to store. The data that you want to store. Right? Hopefully, does it answer your question? All right. So to connect things, right? So let's say you have a root and you have left and you also have right, right? Let's say you create a new node called temp that has its own data, right? And left and right. So what you can do here is to make sure root left points to temp, right? When you do this, basically left would point to here. And then temp left EFT point to now. Temp right point to now. So that in the future, if you need this, you can make sure it points to the new node you are adding in. So you can keep connecting things that would look like a tree this way. All right. So here are the reference. Here are the reference. And now the sample code time, I'm going to implement the linked list using pointer through insertion, deletion, and printing the things in my list. But before we transition, let's do a 4 minutes break so I can set up the demo, right? Let's do a 4 minutes break. We'll resume at 1:10. Is that okay? Basically, someone just deliver a package. I need to go run and grab that quickly before the rain comes in. Um, I'll be back at 1:10, right? We'll do a 4 minutes break and we'll do a demo. Okay, do you see my screen? So in the meantime, basically, I'm just gonna write uh some starter code for our demo, right? And I'm gonna explain it whenever we are back. Okay, are you guys back? All right. So what I do here, for now, right, for now, is I create uh, a quick function. I don't think I need standard library, but just in case I added it. So I create three functions called delete, insert, and print. And delete means that I put in the data, I search if the data exists in my list. If yes, I delete the data from the list. Insert means I'm going to insert this data into my list. And print means I'm going to print the content of my list. And then I will first do a bunch of insertion. And basically, right, I would perform a bunch of insertion, then print the content of the list. It should print 1, 2, 4, 3, 5, 6, followed by deleting 2 and 5 from my list. So it should be 1, 4, 3, 6. And then I try to delete something that doesn't exist, which is 8, which should do nothing to my list. And now I create a node, and because I want to be lazy a little bit whenever I initialize the node, right? Whenever I initialize the node, I want to create a data type called node. Instead of typing struct node all the time, this way I can just type in node to specify that is my node. Inside here, it contains one integer and the pointer to the next item. One integer and pointer to the next item. I'll do the first one, print, because this is the easiest one, right? I have my list, I print everything in there. So to make sure the formatting is a little bit clean, right, I would do something like this. initially print this curly bracket, right? And then while, right? So what do you do? How do you print? How do you print? Can someone tell me how should I print? So you start from the first node, print the content, go to the next node, and loop around that until there's no more thing, right? So what I can do here is to have a temp variable that would go around my linked list from front down to the end of it, right? For temp equals front, temp next. So when I use this arrow sign for struct, when I use this arrow sign for struct, this is basically would be reference for you. Temp arrow. Otherwise, what I have to do is do this star temp dot, right? Star temp dot next. I don't want to do this like bracket star temp. I can replace this with the arrow sign. The arrow sign would first dereference temp from the pointer. It gives you the struct node. Then I want the next. Right? When I'm gonna loop until next is not now. And then I'm gonna go through, right? Temp gonna equal to temp next. And then now we are inside the node, right? You're gonna print a number followed by hopefully to make it organized, like comma. And then temp what? How do I get my data? What do I type in here? What should I type in here? My data. Yes. It's not complicated. Things are not complicated, to be honest. Trust me. So this printing is now done. Hopefully. Let's see if it's correct or not. Now, what do I do for insertion? I want to insert data at the end. I want to insert data at the end. What do I do here? Well, I can do the same thing, right? Loop around until I find the end. Until I find the end. But I do nothing here. Right? And now we have not well, we have the last node, right? Did I forget something? Actually, let me ask you this: did I forget something? Well, actually, yes, I do forget that. I did forget that. What about the case where what? Yes, exactly. Thank you. What if my list is empty? What if my list is empty? What if my list is empty? What do I do? So instead of doing this, right, for both print and insert, what I need to do is not checking temp next. I need to check if temp is now or not. If temp is now, it means I'm at definitely way past the end. I'm way past the end. If temp is not now, I'm at some node. And I'm going to keep going until it becomes now. So I can print from the first to the end. Over here, I can do the same thing. Check if temp is now or not. If temp is now, it means that I need to insert at the front, at the front, right? If temp is not now, it will keep going. It will keep going until we are at the tail end. What's the problem here? If I'm at the tail end, can I insert anymore? Do I have the way to go and insert that? Or do I pass that point already? I'm actually past that point. So this checking is okay, but you need to first check if front is now. Then you insert at the front, right? So temp equals malloc. And then what you do here is now front equals temp. Oh, I want to assign the data, right? And then temp next is now. And then I make sure front now would point at temp because this is the first node in my list. Otherwise do this loop. Which originally do nothing until at the tail, And now we know that temp is at the last node. So what can we do is basically, I need one more. To make it more clear, I need two more, right? Two equals malloc. I first initialize the area for the new node I want to add in. Right? And now I want to say my data is going to be here. What should be the next one? If I insert at the end, what should temp2 next be? This is the node I'm inserting. It should be now, right? It should be now. And what else do I do? What else do I do? So temp points to the last node, right? And then we now we create the new node and want to put this at the end, essentially. So you would set temp next, which is the node before the last node. Should be what? It should point to temp2, right? It should point to temp2, and that's all. That's how you insert. Right? Delete, almost the same thing. Delete, almost the same thing, right? If front equals now, what does it mean if front equals now? What do I do here? Just return, right? There's nothing in my list, so there's no way I can delete anything. Otherwise, right? Otherwise, what do? I'm gonna keep going through the list and see if the data that I'm searching match or not. If it's matched, I'm gonna remove that node. If it's matched, I'm gonna remove that node. So I'll do this. For temp equal front, temp is not now, and right? And what is the other condition that I should end with? This, right? I get the data from the node, and it's not my data that I want to delete, so I'm going to keep going to the next node. I'm going to keep going to the next node. So over here, you either found the data you want to delete, or you are at the end, right? You are at the end. Are you all with me so far? Okay, so what do we do? If right. So if basically you need to check if not at the end, you need to check if, hey, is this really the data I want to delete? Because there are two things that would break that loop. You're either at the end or you found your data that you want to delete. Now that you found my data, what do I do? How can I delete this? No. So this is basically what would it look like, right? Previous node, this node, next node. This is the chain of my linked list. So if I want to get rid of this, to get rid of this, what does it mean? What does it mean for me to get rid of this particular node that I'm at right now? Temp is pointing to this node. I want to get rid of this node. What does it mean? You skip it, right? Previous node would now point to next node. And free temp, free this node. Don't forget the free, otherwise you have memory leak, right? How can I get previous node? How do I get previous node? Right? I'm still have previous node pointing at temp. When I'm done with the loop iteration, temp would go to the next node and it check, hey, is my data there? So previous is still pointing to the previous node. So this is what I can do. What I can do is previous next is going to equal temp next, right? What else do I have to do? This allow me to skip. Previous node now point to temp next. Yep, that's it. And see, let's see if this compile. Let's see if this compile. It does. Yes. See? Let me show you again with a better formatting, because I forgot that when I finish printing, I need to add a new line. So originally you have 1, 2, 4, 3, 5, 6, right? And then you delete 2, which means you're gonna have 1, 4, 3, 5, 6. You haven't printed yet. You delete 5, then you get 1, 4, 3, 6. Let's confirm this again. So insert 1, 2, 4, 3, 5, 6. Print, delete 2, delete 5, right? So you're gonna get 1, 4, 3, 6. Print, and then you delete 8, which will not do anything, right? Any questions? Awesome. That's a great question. So There are two, actually, the question break down into two parts, right? First of all, first of all, notice how temp is not a node. It's a pointer to a node. It's a pointer to a node. So with me so far, basically temp is a pointer. Temp is a pointer. For me to get to the data in temp, right? To me to get, for example, if I want to get temp data, because it's a pointer, one thing I can do is to do this. Oops. I can do this. Right? This is definitely one thing I can do. All right, with me so far, basically I can do the reference temp so that it becomes the struct, and then I do dot to get my data. With me so far, I can do this. So that's okay. But if you do just temp dot my data, what does it mean? You cannot just say, because temp is a pointer, temp is not a struct. So temp dot means nothing. So C would complain. So let's actually compile this, right? It will say, hey, error, I thought temp is a pointer, right? Temp is a pointer. Do you mean this operation? This operation is the same as this. You dereference so that it becomes a struct, right? You dereference so that it becomes a struct, and you point to my data within the struct. So it's the same thing. I use this arrow because it's easier for me. Most people who that program in C would use this arrow. And the next question is, what is this malloc size of node, right? So let me search for the occurrence of node, right? You see, I define the node right here. You see this line I highlight? So this line, what it does is I say, I'm gonna define a type so that every time I see node, the capital N-O-D-E, it's the same as struct node name. So that's why I don't have to keep typing. That's why I don't have to keep typing struct node name. That's a lot of letters, right? So I can replace node with struct node name as well, and it would compile, right? It would compile, it would work the same way. But because I do type def, these are the same data type. These are the same data type. So this allows you to essentially, right? Essentially, use it interchangeably. Does it answer your question? Okay, awesome. So that's it for today lecture part. Let me first stop the recording. We will now go and work on our in-class exercise. In-class exercise is actually pretty simple. We ask you to do prefix sum, but using pointer. Using pointer.